Hello, today I'm going to be covering how you add new menus to the CA6. So in previous videos I've already covered how to set up the build environment and load new firmware onto the CA6. So you want to check out that video first. I've also covered the dev module, which helps you set up new sensors on the hardware side. You might also decide to do this new menu on an existing sensor, and that's perfectly fine. You might have a new use case for an existing sensor that you want a more optimized menu for, or expose some new functionality that way. But if you are planning to do new hardware, you should check out the dev module video first. And now I'll walk you through the steps to add a new software menu. So first, there's this new menu.h file, and it has comments in it that basically walk you through the process, and we'll just sort of follow those here. So the first one is to add a new menu to the web page. So all of the menus on the CA6 are actually just web pages, and I use some JavaScript to generate the HTML, so we'll do that. And it sort of recommends that it points you to the directory, and it says, that the name of the file is the name that the menu will show up as when you're picking from the list of menus. So you want to pick a good name for the file. Let me switch windows here. OK. So here's the CA6 directory, and in here there's this ESP8266. That's the Wi-Fi controller. And in here there's data. And now index.html is the main web page, but the menus are contained in here. So what I'm going to do for this example is I'm going to take an existing menu. Dev menu is kind of interesting because it has all of the different menus, but let's see, we'll pick one that's kind of close to what I'm going to be doing here. So I'll take the sound menu and I'll just make another one, and I'll call this let's see, let's assume we have some hardware that can detect distance, so we'll call it the distance menu. Okay, so now I'm going to open this with Notepad. I have dev menu loaded just because that's an interesting one to look at that has all the different UI elements. So if you're interested in looking at a menu that you can easily modify that has all the different UI elements, check out that one. But for this example, we'll take a look at this distance menu, which I've just remembered it's a copy of the sound module. So, so my fictitious distance sensor is going to be here. So we'll call it a distance. So this just is some help that you can get inside of the web page to sort of how to get started. So you'll have to have created a new piece of hardware called the distance module, and we'll say you plug that into port 1. And let's change this to distance, and we'll change this to distance. So we're creating a slider here, and this ID 0 is how you link data between the web page and the code that we're going to write that runs on the SAM3X, which is the ARM processor inside the CA6. So I usually just start with 0 and then increment them for each new ID I need. So what each of these functions is it's actually JavaScript, but it gets expanded out. And you can look in that that HTML file I mentioned before that was called index.html to see what these functions actually do. That code's semi-complicated, and you generally don't need to worry about it, but it's all open source, so if you want to see what's happening, you can. But for most people, you're just going to take these existing functions and sort of modify them for your use case. So ID 0, and then the next time I need an ID, I'll use 1, and if I need more, I'll do 2, 3, 4, 5, 6. And the maximum number of IDs you can currently use is 256 of them. But yeah, I've never gotten close to that. Then let me bring up a web page now. because this is important. So on this web page, this is a design guide. I'll put a link to this in the show notes. But this is useful because it has what all of these JavaScript functions do. So we were looking at info string. That'll tell you the information. So we're looking at slider right now. It has a lot of cryptic numbers in it, so I sort of wanted to show you that if you're interested in figuring out, where's that one? There it is. So if I go to slider, it'll tell you, oh, this is a UI to display a slider, and it tells you how it passes data, and then it tells you, importantly, what each of the parameters is going to be. It's the parameters, the first one's ID, the second one's the minimum value of the slider, then the maximum value of the slider, then the default value of the slider. It will remember once you've changed it, so this is basically only the first time you load the menu, this value will be used. And then any static text that you're going to display on the left-hand side. So this page is super useful when you're writing menus, because it helps you understand what you need to set all of the values to. Or you can just copy examples, which is another valid way of doing this. I definitely do a sort of a hybrid approach when I'm writing things. I like to try to understand some of what's going on and do a lot of copying and pasting as well. So the way that the values here work, it looks like I'm going to have to update the guide because I don't have a minimum value anymore. It just has a maximum value. Anyways, yep, found some some old documentation there. I'll fix that right after this video. But 4095. So it's a 12-bit ADC on the camera axe. So what that means is the maximum value, it can go from 0 to 4095. And then the default value for the slider. So basically, the way I envision this kind of a sensor working is it'll give you back an analog value between 0 and 3.3 volts, and we'll map that from 0 to 200 or 4095. And so, like, how short of a distance, like the lower this number is, the lower your default for triggering would be. So let's say we just want something approximately in the middle. So we'll say the default's going to be 2000. So this is going to be the distance trigger, and it's not really a level anymore, it's value or something. Then CA text dynamics. So we use this to pass back the current distance value. And it can range for this sensor that we're just sort of imagining. We're going to say that it can be between 0. And then this is sort of the default value. So I'll just put a question mark in there. And so you'll see a question mark when the screen first loads, and then it'll change to the actual number when it reads it. Then you end a menu. Then you also have to do the photo mode menu. So this is all the menu mode menu up on top, and now we're doing the photo menu. And really, there's nothing we need to do for this menu. We're not displaying any. I guess we could, in theory, display the distance. If we wanted to display the distance, we'd copy this guy over, probably name him 2, and we'll say current distance. But I'm not actually going to do that. I'm just going to keep it really simple for people. Also, if you start passing data around inside of the photo menu, that can slow things down. So you really don't want to do that unless there's a really good justification for it. So we're done with this menu. Now let's go back to the IDE. Okay, so we had to do this. We named it. Now we're going to add code to this file, which is actually the code that's going to be running on the SAM ARM processor inside the CameraX. So we're basically setting all the menus values in the web page, and then here's sort of where you take those and process them and then use them to take the photos. So it says take a file, or take some code from menus.h and copy it here, modify it to fit your needs. Recommends maybe starting with sound menu, so we'll do that. And let's see. And it says that the string returned by name must match the name that we used in the name we used for the HTML file, which, or I'm sorry, for the JavaScript file, which was distance space menu. So I'm just remembering that. And let's see, we've got update the names of functions, update the logic. Okay, so basically what it's saying is menus.h is where I put all of the official menus. So by having a new file, it makes it a little easier for people to work on code and not sort of get mixed up with official menus. And you know, if you're merging code and stuff, you'll have fewer merge conflicts because of this. So I just copied all of the code for the sound menu, and we're going to call this the distance menu, and it just says detects, let's just say distance. Then we've got a structure here. This is how it keeps track of data. So there's a pin. This is the pin that's going to be the analog distance value. So I'm probably going to miss changing over sound to distance in a few places, but you'll get the gist of it. The filter, so this is a helper function that sort of smooths out the display of the current values. Otherwise, they're going to be changing too often and not getting the right values. So I created this helper function to kind of smooth things out and get you nice averages or mins or maxes or whatever you're looking for. And then the trigger value is the value that's going to trigger, or the distance. So it stores the distance required. So basically, I'm going to make this menu so that short, when something gets closer than the minimum distance that the user entered into the web page, then it's going to trigger. Okay, so this is distance data. This is a global. I may end up cleaning up how some of this works at some point, but right now I'm just, the code's still not fully baked. But whatever changes I make, it's not going to be hard to change menus from this system to the newer system that I might adopt. But we'll just go with what exists now. I want to give people a feel for how it's pretty easy to add menus, basically. So this is going to be distance name, and now this is the string that needs to match the name we chose for that file we created before. So distance menu is it. Now we'll go distance change this. So basically, we're still going to, a lot of the modules use module 0 pin 0 because that's an analog pin on module 1. So the case calls it module 1, but in the code we're calling it module 0. So you have to remember everything, all the pins, or all the modules, the camera ports, the pins on the aux ports, they're all offset by 1 in code, just because we started 0 in code, but when most users look at things, they don't want to see, they don't want to start counting at 0, they want to start counting at 1. So just keep that in mind. So we'll put this to distance. And we'll keep it as an analog input. So you could do a digital input. There's a couple of things you can do here. You can do outputs as well if you're trying to, control a motor or something. But for this example, just use that. So now we're setting up this distance. What do we do? Oh yeah, so there's that filter helper function that I basically created. And that's what we're setting it up. So the sound used threshold because it wanted to see basically a difference from, it wanted to see a difference in sound. It wanted to detect when the sound changed rapidly. But that's not what we're doing here. We're trying to detect the minimum value. So let me actually, I forget what that's called. Shoot. What is that called? So I don't want to bring up that, but it should be analog underscore m. Yeah, oh, so it's just min instead of minimum. Okay. So analog min will get you that, and then so this is going to basically report back the minimum value, which is what I want because I want us to trigger when the value, when something gets too close, when a value gets too small from the distance sensor, we're going to trigger. And the 2000 is the number of milliseconds until it triggers. So we don't need to set the threshold because that's only required if you're using a threshold value. Now let's change this to distance data again. Oh, so yeah, these two lines are going to be the same. So let's see. So we've got, so this is what happens when the menu inits. This is what happens when the photo mode initializes, which is usually going to be pretty similar for the different points. I mean, you'd have to be using a pin differently, which would be sort of weird. Let's see. Then there's distance. So here, this is what happens when the menu is running. So basically what you're going to do here is you're going to try to collect the values and save them off when it's running. So that's what we're doing here. So we're getting the most recent filtered sensor data with this call. And what this is doing is, remember during initialization, we told it the pin and how to filter the data. So it's going through and getting new values every time it runs and sort of doing the filtering on those values. And then we save that filtered value. And then every 500 milliseconds, that's what this function is going to do, we're going to write that value from the ARM processor over to the Wi-Fi processor, which will then display it on the web page. That's sort of what this thing is doing. And then we're going to handle any incoming packets from the Wi-Fi chip. And the reason you need to do that is because you need to be able to exit this menu mode at the right time. If you never handled any incoming data from there, you would never be able to, exit the mode. So we check for data. I mean, this is all going to be the same. So 0 here is going to match ID 0. And let's see what else is worth mentioning. Yeah, this is something where you're just going to have to probably look at the code for a little while, look at a couple examples, and sort of see how it works. But we're almost done. So you can see the amount of code you have to understand isn't very high. And hopefully this video is helping a little bit. Then there's the distance. So this is the function that runs when you're in photo mode. So basically, I don't want to ever exit this loop. So we just got a busy loop in here that will basically loop until the Wi-Fi processor tells you to exit this. And we're going to check the value from the analog pin that we've stored, which is right here. And then what this is doing is this is biasing the value. But we just want to see if the current value is, let's see, we want to see if the current value is less than, so instead of all of this complication, so value equals that. So I think all we're going to do, instead of all of this biasing stuff, which we needed for the sound menu but we don't need here, is we're just going to say if value is, if it's less, so if the current analog value is less than the distance data trigger value. So this is the value we saved from the previous menu mode as the trigger value. So we're going to say if it's less than this, then set trigger to true, otherwise set trigger to false. And then it says if trigger is true, so basically if the object is closer than our minimum distance, then we're going to trigger the cameras. Otherwise, and then that's it. And then we're also going to check for packets coming in from the Wi-Fi chip. So this is basically just how we can exit the menu or get updates if necessary. Most of the time, this is not going to get triggered. We're just going to be, looping, triggering if we need to, and then going back to the top of this loop until the Wi-Fi chip tells us to exit this menu. And that's pretty much it for the logic portion. So that's by far the most complicated and involved step. Now it says we have to add our new function names to context.h and to menu data.h. And then it says you can get it ready to check in. So that's not it. So the last two steps are in context.h. We've got these function tables. And, oh, this was just an experiment I was running earlier. I'm just going to, yeah, so what it should be is we would go distance name and so we are just adding the new menus that we added, and this PIR sensor thing is actually garbage. I have to remove that. So there, I've added our new functions. So we added 5 new functions, and now I've put them into these function tables. And then the last step is in menu data.h. We need to add our functions as well. So you just go like this. Okay, and then that is the last step. So at this point, you should have all of the changes you need to the code to get a new menu running on the CameraX 6. I'll definitely link in a bunch of documents and other information to help get you started, but hopefully people found this useful. Thanks for watching.